Have you ever wondered what happens to food in space? Does it spoil like it does here on Earth? Welcome to the curious world of cosmic cuisine, where the rules of rot and decay aren't quite the same as they are in your kitchen back home. Many of us hold the misconception that food behaves in space just as it does on our planet. We imagine an apple turning brown, bread growing mold, and meat rotting away. But is that the reality in the vast cold vacuum of space? Well, we're about to take a deep dive into the science behind the space food paradox. We'll explore why your perceptions might not align with the facts, and we'll unravel the mysteries of food preservation in the cosmos. So, strap yourself in for a fascinating journey. Well, you might be surprised to find out that the truth is quite different. But before we get into that, let's understand what makes food spoil on Earth. So what makes food spoil here on Earth? Well, it's an intriguing dance of factors, really. At the heart of it all are three key players: oxygen, moisture, and bacteria. Let's start with oxygen. It's vital for our survival, but ironically, it's also a primary reason food goes bad. Oxygen fuels the process of oxidation, which leads to the breakdown of certain food components, causing changes in color, texture, and taste. Ever noticed how a sliced apple turns brown? That's oxidation in action. Then we have moisture. Moisture provides the perfect environment for microorganisms to thrive. These microscopic critters are everywhere, even on the food we eat. When food is left in a moist environment, these microorganisms multiply rapidly, causing the food to degrade. Of course, we can't discuss spoilage without mentioning bacteria. These tiny organisms are the masters of decomposition. They feed on our food, breaking it down and producing waste products, which can make the food smell and taste off. Some bacteria can even produce toxins that make us sick. But here's the twist. In space, these elements behave quite differently. Oxygen, for instance, is sparse. The vacuum of space is devoid of air, meaning oxidation processes that typically cause food spoilage on Earth are much less likely to occur. As for moisture, well, it's a bit of a wild card. In the low-pressure environment of space, water tends to boil off, meaning food can dry out quickly. But if moisture is sealed within the food or its packaging, it could potentially still provide a haven for microorganisms. And bacteria? They're certainly not absent in space. In fact, astronauts carry a host of bacteria with them. But without gravity, these bacteria behave in unusual ways. Some become more aggressive, while others struggle to survive. So the elements of spoilage that we're so familiar with here on Earth, they're still present in space, but they dance to a different tune. And in the vacuum of space, these elements behave quite differently. Now, let's explore what happens to food in the vacuum of space. Space, the final frontier, where the absence of two crucial elements, oxygen and moisture, creates a unique environment unlike anything we're accustomed to on Earth. These two elements play a significant role in food spoilage. Let's break it down. Oxygen, for starters, is a key player in the process of oxidation. This is the same process that causes an apple to turn brown after you cut it. On Earth, oxygen is everywhere, effortlessly interacting with our food. But in space, there's no oxygen. This means the oxidation process, which can lead to food spoilage, simply doesn't occur in the void of the cosmos. Then, there's moisture. Most bacteria and mold, the primary culprits of food spoilage, require a moist environment to grow. They need water to reproduce and spread. In space, however, there's no moisture. The vacuum of space is incredibly dry, so any water present in the food would quickly evaporate or freeze due to the extreme temperatures. Now let's talk about bacteria. These microscopic organisms are the reason why that leftover pizza in your fridge starts to look and smell a little funky after a few days. But bacteria have a tough time in space. They need oxygen, moisture, and a comfortable temperature range to survive and thrive. Space, with its lack of oxygen, moisture, and wildly fluctuating temperatures, is not a hospitable home for bacteria. All these factors together create an environment where food doesn't spoil like it does on Earth. The absence of oxygen and moisture means the usual processes of food degradation are largely halted. And without bacteria to break it down, food can remain safe to eat for a much longer period. But before you start dreaming of infinite space snacks, remember that while food doesn't spoil in the traditional sense, it does change. The lack of moisture can make food dry and brittle, while the extreme temperatures can affect its texture and taste. So, in the absence of these elements, food does not spoil in space as it does on Earth. But wait, what about temperature? Doesn't heat play a role in food spoilage? Indeed, it does. On our home planet, temperature is a critical element in the spoilage process. To understand this, let's take a quick detour into the realm of microbiology. You see, most of the spoilage of food is caused by tiny organisms called bacteria. These microscopic critters thrive in what we call the danger zone, a temperature range between 40 and 140 degrees Fahrenheit. In this range, bacteria multiply rapidly, leading to food becoming unsafe to eat. That's why we refrigerate our food, to keep it out of this danger zone and slow down bacterial growth. Now let's take this knowledge and apply it to space. The temperatures out there are anything but Earth-like. In the shadow of an object, temperatures can drop to minus 250 degrees Fahrenheit, while in the sunlight, they can soar to over 250 degrees Fahrenheit. These are extreme conditions, far beyond the danger zone. At such low temperatures, bacteria are not just slowed down, they're practically frozen in time, unable to grow or reproduce. On the flip side, the high temperatures can sterilize food, killing off any bacteria that might be present. In essence, the temperature extremes in space act as a natural preservation system. The cold is like the most powerful freezer you could imagine, while the heat is akin to an autoclave, a device used in labs to kill all forms of life on an object. However, it's important to note that these effects are mostly relevant to unshielded food exposed directly to space. In reality, astronauts' food is kept within the controlled environment of the spacecraft, where temperatures are carefully managed to be comfortable and safe for humans. So, the extreme temperatures in space also contribute to preventing food spoilage. But as we'll see in the next scene, packaging and preparation play a critical role in ensuring that the astronauts' meals are safe, nutritious, and even tasty. So, can astronauts take any food they want into space? Well, not exactly. The food that astronauts take into space needs to be specially prepared and packaged to prevent spoilage and ensure it's safe to eat. Firstly, let's talk about the packaging. Space food is often vacuum sealed in pouches to eliminate bacteria and maintain the food's freshness. These pouches are not only lightweight, making them ideal for space where every ounce counts, but they're also durable enough to withstand the harsh conditions of space travel. The packaging also protects the food from radiation, which can cause spoilage. Moreover, the food is also thermostabilized. This is a process where the food is heated to kill bacteria and other pathogens, then rapidly cooled to prevent the growth of new bacteria. This ensures the food is safe to eat even after months or even years in space. But what about the preparation? Well, most space food is ready to eat or can be prepared simply by adding water. This is because cooking in space as we do on Earth isn't feasible due to the lack of gravity. Imagine trying to boil water or fry an egg without gravity. It would be a chaotic mess. Instead, astronauts rehydrate their meals using a special water dispenser that injects the right amount of water into the food pouch. The food is then heated in a small oven before it's ready to eat. This process ensures the food is palatable and safe to consume, even in the challenging environment of space. As an added note, space food also needs to be nutritionally balanced. Astronauts require a diet high in vitamins and minerals to maintain their health in space. As such, space food is often fortified with additional nutrients to meet these needs. So, while food doesn't spoil in space like it does on Earth, it still requires special preparation and packaging to ensure it's safe to eat. So, now you know why food doesn't spoil in space. It all boils down to the lack of key factors that cause food spoilage on Earth, namely bacteria, moisture, and the right temperature. In the vacuum of space, these elements are absent. This makes it an ideal place for food preservation, especially when combined with advanced packaging and preparation techniques. Understanding the science of space food is crucial for long-term space travel. It's not just about providing astronauts with something to eat. It's about ensuring their food is safe, nutritious, and palatable over long periods. This knowledge is key to sustaining life on lengthy missions, perhaps even future colonies on Mars or beyond. So, next time you see an astronaut enjoying their space meal, you'll know the science that's keeping their food fresh. It's a fascinating blend of culinary arts and space science, ensuring our intrepid explorers are well-fed, healthy, and ready to push the boundaries of human discovery.